Welcome back, everybody. Welcome to the second video of this week. This next video might be a review for those of you that have already taken coding in the past. If you have any programming experience, doesn't matter the language, Python, C++, C, Ruby on Rails, but if you do know Ruby on Rails, I have questions for you on why you decided to learn it. But regardless, this might be a review for some of you guys. For other of you, this is going to be brand new content. I'm going to try to go over this at a speed that is going to be probably too fast for those of you that are brand new to this, and too slow for those of you that already know programming, so the right speed for nobody. Let's give this a shot. So we're going to go ahead, come back, create a new circuit. We're going to head over. We're going to just pull out an Arduino. We don't need anything else for this project. All we want is an Arduino, and we're going to go ahead and click on this code button up here. We're going to switch over from block mode to text mode. Block mode is disgusting and should never be used. It greatly limits what you can do and isn't actually how any of this is done. So we're just going to ignore that exists and just jump over to text mode. Sorry, I made a list of things to actually cover here. There is a lot, and we have to cut it down for this video. So we're going to start off by going through the basics, trying to understand what the hell do we actually see when we first loaded this up, and the basics more or less of programming in a very short video. It's going to be challenging, but let's give it a shot. Once again, as a heads up and reminder, I have office hours next week. I don't expect everyone in this call, everyone watching to fully understand how to do this, especially if you're brand new to programming. This is going to be difficult, and please come by the office hours. I'm here to help you out, help you guys out do that. Make sure to give it a shot first. In addition to that, none of what I'm teaching you is at all secret, unknown. Go ahead, look it up online. There are tons of resources out there for you guys to use. It's a very well-known topic. The language we're doing this in is Arduino. If you guys want to look that up, you guys just look up Assistance Arduino Coding online. Wonderful websites available. If you just go look up Arduino functions. There we go. Arduino CC. You can come over. Tons of resources here if you guys need anything. Different functions. If you go to libraries, you can figure this stuff out. Basics on the language. Incredible resource. Incredible references here. Just if you go online and you just look up basics or anything Arduino related, Arduino code. Examples. Built-in examples, tutorials, Blink, so forth. We're going to actually go over Blink in a bit. This is really a well-covered, great community space. There's plenty of resources for you guys to use online, so feel free to use it. Make sure to use it. It's incredible and really help you guys out. So let's go over just the very bare-bone basics of coding. We're going to ignore the Arduino even exists for the first, for this entire video, actually. We're just going to go ahead. We're going to delete everything in here. We're going to delete what was seen right there, and we are going to talk about the basics. Starting up, I just want to talk quickly what we see here. We see void setup and void loop. These are both functions, and this is actually Arduino specific. In C and C++, you won't actually see this. But what this represents is Arduino, when it launches up for the first time, what it's going to do is it'll immediately call the function setup. So it's calling this function called setup, and beforehand it's saying what the return type is. So what is this function returning? Just like a math function, a function in math, you put in a parameter, it returns your result. A function in coding, typically you put in your parameter. In this case, you put it into parentheses, there is none, and you would return your result. The result is void, so it also doesn't return anything. Arduino will go ahead and it'll run void setup one time, the moment that you start it up. And then it will run the function void loop, which, once again, no inputs, no output, and it will actually just keep on looping through this as long as the Arduino is turned on. So, setup is for your one-time things, loop is for your continual things that needs to keep on repeating. So in terms of what we're actually, so we're gonna right now just play around a bit in void setup, and we're gonna get to void loop in just very briefly. So going over to void setup, we're gonna talk the basics about variables. Variables are the bare bone basics of coding, and they are the fundamental part that really what you're gonna build everything off of. Simply, what a variable is imagine a box. Here's a box. Oh, I want to make sure you guys see it. Perfect. Here's a box. I could go ahead and I can write on this box. I'm going to call this box, grabbing a Sharpie, A. This is box A. Box A, I can say, is going to be storing money. Well, conveniently for me, I can take some money. Right here we have 4 coins, Mexican pesos, I believe, and we can put it into the box. This box, A, now stores the value of 4 Mexican pesos. And that is essentially the idea of what a variable is. It's nothing more than a box that stores information, and it says what type of information it has inside. That's the more in-live demo version. We're going to now quickly show over the nice CS version of this, which is called a railroad diagram. Essentially, re-explaining the exact same topic. How do we make these variables? Well, the first thing we could do is say if this variable is going to be constant, or it's going to be constant, or it's going to be able to change. For example, coming back to box A, if I had more money to put into this, I wouldn't make this constant. This variable can change. Variable A can change. However, if this was constant and I couldn't get any more money, well, that would be a depressing life, but it would be constant A, and you'd want to set this as a constant, as it'll make your code run better. Next up, you're going to want to say what type of information is stored inside of your variable. You can either have an integer, which is just the standard integer, negative number to positive number. It stores between 2 very large values. I forgot exactly what it was. Irrelevant. You can look up if you're interested. A float, which is a decimal value. And there's plenty of other types. You could store a byte. You could store a bool, which is a true or false statement, and so forth. There are plenty of different stuff you could store in a variable, and there are plenty of different types, and you can look them up all online, depending on what you need. Next up, we're going to give the variable a name, and then we're going to set it equal to its value. So, enough talking, let's actually do this. Let's make A. So, let's first say that, imagine I can get more money. So, what we're going to do is follow our diagram. It's called a railroad diagram. And we're going to say, so it's an integer. I'm storing an integer amount of money. I have 4. Next up, going back to our diagram. The name, well, this is going to be money. And I want to say it's equal to the value, which is going to be 4. There we go. Now, if I couldn't get more money and I was stuck at this, I would say const int money. So this is a constant integer this is a constant variable of type integer that currently has the value of 4 inside, and that cannot change throughout my code. But let's get rid of that though. And let's go a bit more with coding and what we can actually do here. It is completely possible for me now to go ahead and make another variable. For example, int income equals 1. So I get an income of $1. Now, imagine I can add these together. I can say money plus income. Now, I would add the 2 together. However, I need to store this algorithm together. I did an operation, adding 2 together. I need to say this is now what my money is equal to. My new money is equal to money plus income. Very quickly, I've been doing this intuitively. I should probably call it out, as a good teacher probably would have. After each line of code, you put a semicolon. The semicolon is essentially saying, this is the end of my line. It is, you need to have it. If you don't have it, your code won't actually compile and run. So let's go ahead and run our code. You can click Start Simulation. And our code runs like a charm. Now, it runs. What's happening here is, or what this is simulating, is this code's actually running on the Arduino. Issue is, though, the Arduino doesn't actually have a screen. There's no way for me to actually see what the result is. I don't know what money is anymore. I need a way to display these values. And fortunately, though the Arduino doesn't have a screen hooked up to it or some way to communicate with me that, it is connected via serial port back to our computer, which is the USB. So let's stop simulation, and let's introduce this concept of serial. Serial is just a communication between our Arduino and our computer. Serial isn't specifically for Arduino, it's just this type of communication. If you want to look up more on serial connections, feel free to. Plenty of resources online, very well known, very well discussed topic. And let's find a way to actually see some more information. So the first thing we have to do is write a function that's called serial.begin. Well, we have to call the function serial.begin 9600. And this is saying initiate serial connection with the Arduino at a baud rate of 9600. That's just a fancy way of saying the speed at which you're communicating. Don't worry about that one. If you change that value, you're going to start seeing weird values start appearing. The Arduino could communicate at different rates, and you just need your machine to match it. So that works like a charm. Then, that just initiates serial connection. Here, I can run my algorithm, and after, I can write serial.print money. Now, if I click down here and open my serial monitor, and I restart my simulation again, we can see the new money value, which is equal to 4 plus 1, which is equal to 5. Stop simulation, start it again, and we see 5 again. Now, imagine that I wanted to see my money before and after. Well, I could simply write serial.print money. Then I can even, I need to make sure I have my semicolon. I can even put a text in there, serial.print earning money. There we go. We can start simulation again. And there is an error in the code. So let's see why quickly. Very helpful. Money was not declared in the scope. There we go. So the error right here is saying I'm trying to print the term money. Well, that's a problem. I never said what money was yet. I'm saying print the term money, but the code runs like this, top to bottom. I never declared money. It doesn't know that money is a variable yet. So let me go ahead and Command X this, and just put this at the beginning of my code. So now I can actually know what money is, the variable, in order to print it. Go ahead, close the error, restart simulation, and there we go. Serial monitor, 4, earning money, 5. Now, this doesn't look very pretty. Once again, declare these errors. This is just an annoying part on Tinkercad. You can go back, go to line, and go back. Just get rid of red. This is all on the same line, so it doesn't look very good. So instead of using serial.print, we can actually use a different function, serial.println, which is this, you have to stop simulation, right code. Serial.println will simply make it print on the next line. Very simply. Start simulation. There we go. I should clear it first so that it actually works properly. 4, earning money, 5. There we go. Now you have an introduction to serial, variables, and idea of essentially what, you have a very bare bones idea of how functions work. We can write our own custom functions and call our own custom functions, but that's going to be a later exercise to do. Now I just want to go into all the other types of arithmetic operations and such you can actually do here. There's a few of them that are going to be interesting, and we're going to go ahead and just go through all of them. So, starting up, of course, I can lose money. Money is equal to money minus 1. Serial.println money. Oh, so many typos. Go on, I cleared the code. Start simulation. 4, earning money, 5, and then 4, I lost the money. Nice and easy. You can add, subtract variables and such. Following that, the next one I want us to discuss is going to be multiplication. Very intuitive once again. Money equals income times 2 plus money. Standardly, arithmetic follows standard order of operations. PEMDAS, if you remember it, very important. Just follows the exact same operations, nothing new here. If you're ever stuck, just throw parentheses on and it solves your problems. And go ahead, serial.println money. Start simulation. And there we go. 4, then 1 times 2, which is 2. 4 plus 2 is 6. Nice and easy. Of course, there's the division operator. So we're going to do that one quickly. Println. Sorry, we got to first divide. So money is going to be equal to money divided by 2. Divided, simply being a slash. Serial.println money. Go ahead, run it again. 4, earning money. 5, 4, 6. 6 divided by 2 is 3. Nice and easy. And the final operation that I'm going to want us to discuss today is what's called the modulo operation. What the modulo operation does is it simply gives you the remainder of a division. So if I currently have 3, which is the value of money, and I say money equals money modulo, which is used with the percent symbol, modulo 2, that's essentially telling me if I do 3 divided by 2, what will the remainder be? Serial.println money. Start simulation. The answer would be 1. 3 divided by 2 is going to fit in once, and there's going to be 1 left over. If I do modulo 3, the answer is going to be 0. There is no remainder. This number is clearly divisible by 3. Even if and this works for any value, any multiple of 3 will be divisible by 3 with no remainder. So I can say money equals 27 here. Restart simulation, and we'll still get our final value of 0. This modulo operation is very helpful, especially if you're trying to count stuff or do stuff over certain intervals. So let's go ahead and delete up to here. And let's learn one new operation, which is the if and else statement. An if statement is just going to say, if some condition occurs, do this. You can add an else statement if you want to. It's not even needed. Saying that, and that else, do something else. I believe I said else statement instead of else statement. So we're going to go ahead. And we're going to go through what logical operators are. The 3 logical operators to actually care about, I guess we could go through 4 here. And 3 plus an adjustment would be equals equals, which signifies that 2 things are going to be equivalent to one another. So for example, if I wanted to know the answer to, let's go ahead and delete up to here for now. If I wanted to know if money, I could do serial.println money equals 4. This is going to now print whether this equivalency is true or not. Start simulation, and we get 1. Should be noted 1 means true, or any integer value actually means true, and 0 means false. So That's that operator. How about money equals to 1, just to show the flip side. And now we get a 0 here, because money does not equal 1. Well, does not equal also has an operand, which I will show quickly. It's just exclamation mark equal. Money does not equal 1, which is true, so we got a 1. The next ones are, of course, there is greater than symbol, greater than or equal to, less than, and less than or equal to, all fitting into the exact same rules. And we can apply those conditions to an if statement. So an if statement is written if, open parentheses, condition, money equals for. There we go. So you close condition, open curly brackets, go to the next line, serial.println, we're going to write rich. Then go enter, close curly brackets, oh, don't forget semicolon. Else, an else statement is just saying if this didn't happen, do this, which means it doesn't need a condition. The only condition was the if statement not being true. Open curly brackets, serial.println, not rich, sad face. There we go. And we can go ahead and run this. Oh, and there is an error. Yes, there we go. If we look right here, I opened the curly brackets of else, but you got to make sure you close it afterwards. Oh, close that, start simulation. And there we go. Serial monitor. It tells us we are rich since we have money equals 4. You can, of course, change this. Say money greater than 4. Well, that's not true. So we are not rich. And there you go. That's the basic of if statements. You can have multiple if statements if you want in a row, and you could do a lot of stuff with it. And that right there is going to be the basics of coding in Arduino. In the final lesson, I'm going to go over actually using the loop statement and doing stuff actually related to getting the pins on the Arduino board to activate properly and such. But all this information will come in. And then for the homework assignment, on this section, I'm just expecting that you guys, for this section, go ahead, write yourself some bit of code, something just show you toyed around with it. Write something small code, take a photo or so, take a photo or two of it. Write a few different code. Just get comfortable playing around with variables, adding them, subtracting them, showing them on serial. Here we go. I'll make the unofficial assignment here on the fly. Show me a code that show me one code that has an if statement in it, one code with a modulo statement, and one code that uses various different arithmetic and logical comparators. So I want 3 different lines of code, very basic stuff. They could each be 2 lines and very simple. And go ahead and explain the stuff for your website. Shouldn't take you guys long to do.